Thank you. So just an introduction. I've been at Mozilla for a little over 4, almost 5 years now. I've been doing security and web app security stuff for a really long time. That's why I have no hair and a gray beard, probably. I live in New York, and a lot of people probably know me in the security world best through one of my projects, FuzzDB, which is pretty popular with pen testers. And I live in New York City, and I'm a former, happily reformed CISSP. How does this work? So just wanted to talk for a second about the overall agenda. You guys have seen it all because it was in the presentation guide. So we're going to talk about a couple things today. A lot of it has to do with how we deal with security and open source at the same time, which is tricky. In the past, I've worked a lot did a lot of corporate security type stuff before coming to Mozilla, and a lot of consulting. And open source is very different than in the world where people finding out about how your stuff works can be scary. And as I've learned, it's actually not quite as scary as I once imagined it to be. So we share a lot of stuff at Mozilla. You've probably heard of us. We make a web browser, and it's all open source, and a whole bunch of other software like Bugzilla and all kinds of other things that are pretty popular. And so what that means is we have a little bit of a different threat model than a lot of organizations do. So a lot of you have probably heard of MITRE CWE, the Common Weakness and Enumeration Database. And source code exposure is considered to be a vulnerability. For us, it's pretty much part of open source software, hard to avoid. And doesn't mean that having your source code exposed is a security weakness, as I've learned. It means that the attacker can examine your code for flaws. That's something you kind of have to always assume anyway, because you have to, at least from my perspective, assume that the attacker is going to have full knowledge. And security by obscurity is you can hide stuff from people, but only for so long, and it could be that the attacker has, there's lots of ways that people have of getting access to internal system and documentation, et cetera. So obviously, their remediation, this doesn't look so good up here, which says to remove the source code from being available and visible, doesn't really work out so well for us. I think there's something wrong here. Hold on one sec with this adapter. That's okay. So what you are not seeing on there are some, can you help out a sec, or I don't know what's going on here. Maybe I'll try a different one. Hold on. It'd be a lot better if you guys could actually see the slides. There we go. This is a lot better. So as you can guess, it takes a lot of web services to support a modern web browser. So for example, Firefox accounts and sync and add-ons and plugin check and crash reports and telemetry and all this other stuff. These are all web services. They all have a lot of stuff that would be interested to all kinds of different classes of attackers. So when we think about what our threat model is at Mozilla and in terms of where our risk is, from my perspective, ultimately, it's that we're not really ultimately the intended final target for attackers, but we make a really attractive intermediate target. We have like 400 million something users out there. Browser bugs are pretty valuable. For example, I think it was last year, you guys might have heard that there was an exploit in pdf.js, which is the JavaScript viewer for PDF files that we came up with in order for people to not have to use the Adobe Acrobat plugin, which is, that and Flash are kind of like, two terrible things that have plagued browsers for a long time. And they let us know that there was an advertisement on a news site in Russia that was serving a zero-day exploit for PDF.js that searched for sensitive files on on your computer and would upload them to a server that appeared to be in the Ukraine. And as it turned out, they got it because they had access to the security bugs in Bugzilla through using somebody's legitimate account where they had reused a password from someone else. There's a limited number of people with security bug access. This happened to be one of them. And since then, we all use two-factor authentication for that, make it a little bit harder. So Bugzilla is really the website of ours that scares me the most. We've got about 3,000 website endpoints overall, including all of the community sites. Bugzilla scares me the most because it contains live bugs for all of the backend services and for the browser. And so also, what's our most sensitive data worth? So there are companies out there. We have a web bounty program and a bug bounty program. And there are companies that pay for security bugs for our products, and sometimes more than we do. So you can't see it here, but like Zerodium pays about $20,000, for example, for certain types of Firefox bugs. We can't really match that, never will. And the reason why we still actually have bugs reported to us, of course, is because there are a lot of researchers who want to find the bugs and report them to us. We pay enough that it really is worth it for them to do it. And if we got into a bidding war with companies like Zerodium, we could never keep up with that. The economics of it would be pretty impossible. And then, for the bugs that do go to places like this, where do they go and where do they end up? So let's talk a little bit about the economics of zero-day bugs. Since we, $20,000, let's say. You guys, you probably have heard, like in the last couple of years, in the last year, the FBI paid a university about $1 million to work on a Tor exploit. We'd like them to tell us what it is, but they want to keep it to themselves. And that $1 million, relatively speaking, was actually a bargain for the FBI. It sounds like a lot of money, but it was actually really a bargain. Because you have to consider that $1 million is compared to the next available substitute of being able to track down the users that they wanted to track down, which probably would have cost them significantly more than $1 million. State actors have virtually unlimited budgets. They don't face resource constraints that are typical ones. If they need more money, they pretty much just print it. And so this is part of, this is kind of part of what we're facing, and it's not really just from the US, it's from, pretty much most countries these days have this kind of program. So The Intercept is Glenn Greenwald's investigative journalism website. The screenshot on the left is from a leaked NSA slide deck, and if we take a look at what was highlighted down here, so essentially they go out and look for people who have privileged access to systems, system administrators, security people, and so probably everyone in this room is really personally a target for one place or another. And it doesn't always seem like that every day, but this is the reality now. And so it says, by infiltrating the computers of system administrators who work for foreign phone and internet companies, the NSA can gain access to the calls and emails that flow over their network. So they have active programs for this. And like I said, it's not just the US, and I'm not picking on like North Korea or Russia or any other country because they all do this. They're just different actors who are involved with this, and they have their own interests, and we may have our own interests, and they don't always meet each other. And because of Mozilla's add-ons, the browser is very modifiable. The Tor browser uses Mozilla. It's the most popular browser for people who are interested in privacy, which also makes it the biggest target for that. We share almost everything. So we were talking about open source a minute ago. So all of our source code and design documents, it's all available on our wiki website and Mozilla Developer Network. Very different from when I was doing work for like banks and hedge funds and so on. The implementation debate is pretty much dead. The implementation, by that I mean that the question of which is more secure, open source versus closed source proprietary software. Ultimately, there really is no relationship between the number of vulnerabilities that have been observed in open source versus closed source software, but only open source software can really be fully and freely audited. You can look at object code, and for proprietary applications, takes a lot more work, and it takes a little bit of a different skill set sometimes. And you don't necessarily have access to all the design documents and really understand how it works, and you usually can't email the developers and ask them questions like you can with us and other open source projects. So what do you do? It's like I said, it's a lot different. And a friend of mine, this guy Perry Metzger, he runs the cryptography mailing list. Some of you might be familiar with it. It's the successor to the old cypherpunks mailing list from the 90s. Came up with this phrase, and I borrowed it from him, about ratcheting it up. And so what you gradually do over time is to focus on the areas you can and reduce the attackable surface. So for example, some of the things that we're doing now are like, you may have heard of Rust, which is a programming language that we developed. It's a lot more memory safe than C++, which is what browsers are, our browsers written in now. And so there's a project called, so the language is called Rust. There's a project called Oxidation, which is to gradually move pieces of the experimental Rust browser that we've built into the main line of Firefox code. And then also there's electrolysis, which is process separation for tabs and for plugins and so on. Also through Mozilla open source support, we announced a program recently where we have a pretty significant budget for doing work on all kinds of other open source projects, particularly ones that we rely on. So there's a couple that we've already done. So that'd be like LibJPEG Turbo and PCRE and PHP MySQL admin. And 41 or so bugs were found in that first round, and we just announced a whole bunch more money and other projects we're supporting, and this is an ongoing project. So we're making the resources available for that. So, like I said, one of the ways to lock it down is to focus on the areas that you can, and at some point, enough of it will, it'll be enough to make the possible kill chain a lot smaller, so that there's a lot less possibility for bad stuff to happen. Bug bounty program, like I mentioned before, I started running the web bounty program later last year, at about the same time that I started doing a reboot of our application security program. Not to say that we hadn't been doing a lot of stuff all along, but web services have really very much exploded at Mozilla in a good way. There's a lot more stuff than there had been. So like Firefox accounts and sync and a bunch of the other back-end stuff. And this stuff grows pretty quickly, and we realized that we needed to take all of the different security efforts that we were doing and have an overall view of where it was and figure out where we wanted it to go. And so we're actually using OpenSAM for that, and I'm going to talk about that in a little bit. And what we realized is that the bug bounty program for us really became one of the best sources of information for us about our program. And the reason why is that bugs that are submitted by external reporters, they reflect what it is that our processes for detecting and preventing them in the first place are missing. So we use it to inform the rest of our program, and we're going to talk about that a little bit more in a minute. Essentially, what we also did was to rethink the way the bounty program actually works, because we wanted to make sure that it encourages reporting for the kinds of bugs that we would like to hear about, and also because, from the realization, talking again about the economics of bugs, that we're competing. not just with every other bounty program out there, but also with all of the other possible available uses of the time of the researchers who are generous enough to be testing our stuff. Other thing that we started doing is to have a bug pipeline that was a little bit better defined, and to think about what kind of information we can extract from it and where we could use it and what we could use it for. So, because if it's also important that somebody owns something like this, because if there's no ownership, then nothing's going to really happen consistently. So what we started doing is having internal communication channels related to all of these bugs. So it's not just a matter of the bug coming in, getting verified and fixed, but also doing variant analysis and looking and working more closely with when bugs are reported to us that actually turn out to be part of some library or framework that we're using, and then find all the other places where it might be and figure out what the root cause of it was and what do we need to do in order to keep from making that happen again. Also, again, for the economics of the bug bounty program, because the bugs are paid for by based on the security value of the bug, taking a look at those kinds of metrics becomes really useful because it gives us a really good idea of where the biggest problems are, because there's a direct correlation between the amount of money we're paying for different kinds of bugs for different kinds of platforms and what we need to care about and where our risk is. So let's take a look at what our web bug intake workflow looks like. And so we do this a little bit differently now than before. So external reporters, we have a defined team of web bug verifiers. I picked Mondays because that way I get to look at 3 days of bugs, and I love bugs. The bug reports end up going to, so all the bugs actually make sure they all go to whoever the point of contact is for a particular website or application or service. That goes into the software release process, and it also, those bugs end up informing the rest of the program. And we'll take another look at that slide in a different view in a sec. Our bug bounty program actually came from what was the first bug bounty program, because Mozilla, some of you may know, came from Netscape Navigator, eventually turned into Mozilla Firefox. And so, the program itself is pretty old, and it started back in 1995 for Netscape Navigator 2 beta. And browsers look a little familiar, a little similar to how they used to, but a lot different also. These are the two guys who have, before I had started working on the web part of it, Chris Hoffman left recently. He had been at Mozilla for more than 10 years and has been working on browsers for 20 years continuously, probably, I think, longer than anybody has done. He's probably the longest, as far as I know, the longest working person continuously on web browser security. And Dan Veditz is, for those of you who follow IETF standards and W3C standards, his name's on a lot of those. Really sharp guy, and kind of like a walking web security encyclopedia. So our bounty program today, some of the things that we had changed are to, we wanted to be able to shift the curve to, oops, sorry. What's that? To more high value, difficult bugs, but also to not discourage people from telling us about lower risk things that we would still want to hear about. This is an area that still needs a little bit of work. We have I'm on the enterprise security team. There's about 10 of us. A few of us are dedicated specifically to web security. Then there's also a cloud services security team. Then there's the platform team, and there's a fuzzing team. We get a lot. We get bugs reported, and we have a lot of other stuff to do. And so the human element of handling some of it is, can be the tougher part. But what we're trying to move towards right now is to be able to. We only pay for bugs that are from moderate risk to higher right now, and are putting people who report lower risk and informational bugs, you know, there's really nothing that's happening right now. And we would like to get those, and you know, just a function of time, and that is coming pretty soon. So we'll be shipping people like, you know, swag and other stuff like that, and putting them on the Hall of Fame soon. But we're still moving to that. We've got about 3,000 websites total, but the bug bounty list is not that large. We started generating metrics about our vulnerability trends, and we're going to look at the next slide about that, which told us some really interesting things. And because we've been collecting them for a long time, it's all in Bugzilla, but hadn't really been getting the most value out of them. And the thing that helped us do that was to go through, for the last few years of bugs, to come up with a more detailed taxonomy for how we tag the bugs and bug categories. And then we suddenly had this huge database of, you know, vulnerability information that we could go back and see how we've been doing, and it told us a lot of things where, you know, when you're looking at the bugs on a day-by-day basis, it's a lot harder to see the kinds of trends that we can see now. Also, the bug bounty program became a really good entry point for the team that I'm on now, the enterprise security team, to be able to interface with all of the other development teams. Something that's a little bit different about Mozilla than many places is that we don't tell developers to use any particular, particular tool set. If somebody starts, when a project starts, they figure out what the best, you know, language and framework and so on to use is, and you know, we provide them guidance, but we don't tell them what to do. Which is kind of fun because you get to see a lot of things. Also, though, it means that standardization can be a little tough. Though, by and large, most of the web apps these days are in either Python or Node. So there's about 3,000 sites, like I said, including community sites. So we help, you know, because we've got lots of community members and they get involved in things like internationalization, especially because I didn't know this until I started working at Mozilla, but something like 60-something% of Firefox users are not English speakers at all. So the bounty program, like I said, gives us a really good avenue for discussing security topics with all of the development teams, which include, you know, paid developers and community members. Some of the things we also changed were to just provide better instructions on bug reporting. So previously, we had been getting bugs primarily through email to the address, you know, security@mozilla.com. Some of you may know about there's a interesting thing in the TLS protocol where there's a flag that can be turned off to say don't use TLS. I think it's the TLS start or something like that. I forget. Anyway, this is actually a real problem out there because if somebody man in the middles between mail server connections, then it becomes easy to intercept mail messages. Obviously, we don't want that to happen to the bugs that are getting reported to us, and the organizations that are the most capable of doing that are the ones who are most interested in those kinds of bugs. So now we accept all of those bugs only through web form on Bugzilla, for example, and not through email at all, and explicitly direct people to do that. Also, we explicitly tell them not to report bugs. You know, we have a lot of source code on GitHub and other places like that, and don't report security bugs through there because there's no way to make them private. Only report them through Bugzilla. And then also the reporting instructions. So you know, we ask people to explain the attack scenario, to provide a step-by-step, way of creating the exploit condition, and then also to make sure to go through and recreate the exploit themselves, pretending they have no knowledge about it and just using their own instructions. And it makes it a lot easier for us to triage the bugs. So these are the stats from the last year. And cross-site scripting was the #1. And actually, the majority of those bugs were reported by one tester. And for Bugzilla, and it was Vladimir Palant, who's the guy who does AdBlock Plus. So these are some of the changes that we've made. The idea driving it really is that bounty hunters really shouldn't have to search hard for information about the sites that we want them to test. So we have a really explicit list of hosts. We tell them about the kinds of bugs we'd like to find about, and we provide them links to as much technical information as possible about those sites to make their job easier, and also because, like I said, we're competing with their, for their time with lots of other things. So most of the next part of this talk is about the knowledge problem that makes doing qualitative comparisons of risk so difficult, and then we'll talk, unfortunately, a lot more briefly about what's actually possible. So I guess the question is, what does it mean to measure risk? Or maybe this is like reason 65, 537 of why I let my CISSP expire. So we like to measure security, or imagine that we can. Management defines goals and comes up with some kind of a measure and establishes quarterly targets, communicates the target in terms of some kind of an agreed measure, and people do generally what they're being measured on. Usually it looks something like this. And what ends up happening is something kind of like this. But what ends up really happening is a little bit more like this. And the process sounds logical, but it can really be counterproductive. Overloading a metric with too many purposes can lead to a lot of unintended consequences. So if your goal was to reduce bugs by 50%, and you implement a web scanner that increases the number of open bugs you have by 60%, did you succeed or did you fail? I don't know. There's really no way to know. We can account for the addition of the scanner, but there are too many variables that can't be accounted for, like new code and false negatives, attackers developing new tools and techniques, and insider threat. There's no way to know what can't be accounted for. And it's too easy to assume if we take a look at these two, if we ask ourselves which of these is safer. So like the light blue one says Q1, high bugs fixed. Second one says Q1. For the two different apps, so which one is safer here? And what do we learn about this? Really not too much. And it kind of reminds me, there's this joke about the policeman who sees this guy searching under the streetlight for something or other, and he asks him, it's nighttime, and the guy looks drunk, and he's like, what are you looking for? And the guy says, oh, I'm looking for my car keys, or I lost them. Not a thing you probably want to say, but he's drunk. So anyway, the policeman helps him go look for him, and then they ask him, are you sure you lost him here? Because they spend a few minutes looking for him, don't find him, and the guy says, no, I'm actually think I might have lost him in the park, but the light is here, so this is where I'm looking. And that's what we end up doing a lot of the time, unfortunately. So what can we actually measure? If we think about what security is, you can look in the dictionary and see some definitions, and we often use these kinds of charts to describe security, but it doesn't really mean all that much. So should you, for example, ignore a 49% probability of risk that would cause a 49% of maximum loss? And why would you want to pay attention to a risk that has a 51% probability of occurring with a loss of a 51% of maximum loss? How much can we actually know about any of this, and with what kind of confidence interval? Not really a whole lot, and certainly not really enough to make use of tools like this in a meaningful way. Ends up being garbage in, garbage out. We don't know what our scanner coverages really are. Asset valuation, to whom or for what. And unless it's a commodity with a market price, this is pretty much garbage in, garbage out. Threat is a singular word. How many threats are actually a single factor? Not really many. What if several of them coalesce into one event? This doesn't become all that meaningful. Qualitative assessments are also problematic. So this is from CISSP certification guide. And it's also not really meaningful. It says the downside of performance. Let's go back a second. The downside of performing a qualitative assessment is that you're not working with dollar values, so it's sometimes harder to communicate results of the assessment to management. Even though the qualitative values are just as subjective as the quantitative values, because how much is your user database actually worth? You can't really put a price on that, because the only market value there is for it is in criminal black markets. And the only way you could find out what it is to go try to sell it there yourself. So this kind of becomes an epistemological problem. And if we think, like, what is knowledge is something that philosophy professors still debate, and we're in Rome, and it's been a debate that's going on for a long time. So when we talk about security verification and assurance, neither of these terms are really all that accurate, because the information that we get from this kind of stuff doesn't really give us any of those things. One of the ways that you can ratchet stuff up, like, so there's technical ways. So these guys came up with using a formally verified browser using an interactive theorem prover, and it's really cool because they're able to demonstrate the security properties of parts of it using a form of calculus. It's really cool. However, most of the kinds of problems that tend to plague web apps, it really can't do anything about, because it protects the kernel, but not really all the rest of it. And so we discussed what's hard to measure, so what's actually left. And even these can get tricky, because, like, what does complete coverage really mean? Like, we like to think about this kind of stuff, but it's not something you can really define accurately. Or, like, time to close breach. How do you have any certainty of whether the breach was actually closed? And so this is why I think executive summary becomes really important when you're doing this kind of reporting. A lot of the time people like charts and graphs, but charts and graphs and pure numbers don't really give this kind of context. And the information of what you can't report is just as important. DevOps is a pretty popular thing these days. We use it ourselves. But there are a lot of categories, the idea is you have, continuous testing and development and deployment. But more tests doesn't necessarily equal more secure software if you're not doing the right kind of tests. So we like to try to find ways to measure things using, like, a maturity model. We started using OWASP, OpenSAM for this. I've used it a bunch before. It's pretty nifty. So, the idea of a maturity model is you have a standardized assessment, and you can compare the results of different organizations to each other. And so, like, there's this organization, they do testing for all kinds of stuff, you can see a list of all of them. And this is from their website. It says, according to management best practices. What does that mean? Maturity level. Again, we use this term maturity level, but it's really, the descriptions we use are really vague. And to compare your maturity level with other organizations becomes tough, because we're assuming that the other organizations actually have good self-knowledge and are reporting accurate information, which is not something that we can actually go back and verify. So we're comparing ourselves against information that may or may not be useful and may or may not apply to ourselves. A lot of self-delusion becomes possible. Like, there's the idea of having self-service questionnaires to get information, and the person who's getting the questionnaire probably doesn't have sufficient domain knowledge to do a good job at it. Interviews really work the best when it's done by someone who is, security-minded and really skeptical. A lot of the time, they'll uncover things that the person being interviewed really would not have thought of. The benchmark data, like I said, becomes problematic when you're comparing yourself to other organizations. It's aggregate information, so if you see these numbers, like, OpenSAM has numerical levels of maturity, but these are aggregate numbers that don't really tell you very much about the actual practices that are being measured inside them and how they're being measured. Then there's also cognitive errors. People are really bad at being good observers and reporters. So one of the things, the other problem that can happen with maturity models, and so with OpenSAM, I have in the past used it, like I said, and it's really hard to figure out how to do the roadmap. And so I submitted this as a contribution to the project recently, so as an addition to the spreadsheet, to be able to use the spreadsheet to do this also. There's like 3 or 4 more slides. Is that okay? Hey, thanks. So for those of you familiar with OpenSAM, there's the roadmap tool. This is a different way, a sanitized version of a different way that I like to present it to our internal audiences at Mozilla. It's a little bit more useful than just a stepped graph. So for example, you could just as easily make the left column when the white boxes show governance, construction, verification, operations, and use it to tell the story for the OpenSAM roadmap. I actually use multiple of these to be able to communicate the program at different levels and help people understand it. Sounds like I might hate OpenSAM, but actually like it a lot. The things I really do like about it is that it gives you a framework for thinking about making changes in a quarterly way, and in an incremental way. It gives you a good way to communicate your intent. One of the problems in a lot of security organizations have is, getting viewed as the bad guy because they go to change something. The change has been planned for a long time, but it hasn't really, this long-range plan can be hard to communicate in a good way. And the maturity model and this kind of approach gives you a good foil for doing that. Just the last thing I wanted to mention is one of the other things we are doing inside of Mozilla now is to have a red team. So we've done a number of exercises now. There's a lot of people who do security work who are developers who work on all kinds of things that you don't even know that they know a whole lot about security, because they're working on for at least for us, stuff like the rendering in the browser or something like that. And so we've started doing these red teaming events on a regular basis and it's been really neat because the other thing that it helps us do is to just build a security community to, again, give us the opportunity to talk about security with people from different parts of the organizations that we might not always get to talk to, and it gives them a really good reason to be more interested in it. Not that they're not interested already, but because they have their own sets of goals, and we would like to communicate stuff to them, and they just might not always feel like they have time, and this gives us a good, like I said, a good avenue to have these kinds of discussions and having stuff like internal mailing lists about just talking about cool security stuff that's happening that you would want to either with bugs that get reported through the bounty program or external news stories. So just to summarize the end of it, radical open sharing of documentation is a heck of a lot less scary than it sounds and a lot less scary than I thought it was almost 5 years ago. Security doesn't yield to qualitative really or quantitative measurement all that easy, and it's been easy to spend a lot of time generating metrics that don't ultimately mean all that much. The bug bounty program and having one is a really good way to that and the maturity model. These are pretty much what are guiding our AppSec program now. Like I said, the roadmap, the maturity model helps us create the roadmap, and the bounty program helps tell us what it is that we're missing. And looking for ways to create cross-organizational teams to get people talking about security is also a big plus. So I wanted to say thank you, and would be happy to answer any questions. Sure. Sure. Well, for starters, we've been. Yeah. So the question was, why are we using our own platform for the bug bounty program instead of using BugCrowd or one of the other, bug bounty as a service type platforms? Reason is that so we've been doing it for a really long time, and the processes for it are inside of Mozilla are pretty mature already, more mature probably than anywhere else, just by virtue of the fact that our bounty program ultimately goes back to 1995 or so. So after, it's not really a huge amount of, that part of it is not really a huge amount of overhead for us. Also, we actually get a very small number of false positives get reported, especially since changing the reporting documentation. Additionally, very often there are bugs that get reported where it turns out that the risk itself is very low, or it turns out to be a false positive. However, when someone who is very familiar with the platform that the bug is being reported for sees this false positive, they realize that the person actually did find something, but it turns out to be something other than what the person reported. So if we were to use a platform like BugCrowd, they are not as familiar with, with our software as we are, and we would miss these bugs, and some of them have turned out to be really interesting things that we end up actually still paying the reporter for, because they led us to where the problem was. Otherwise, we would have just completely missed it. And that's really probably the biggest.
What's your sense of the value of trust as a kind of security improvement?
Trust?
Are you seeing much benefit from Rust so far?
I'm sorry, I couldn't hear.
Are you seeing much benefit from Rust as a migration for security?
Oh, from Rust?
Yeah.
Well, Rust is, so yeah, he was asking if we're seeing a lot of benefit from Rust. So far the answer I would say is we're getting there, because the oxidation project I told you about, which is moving Rust code into the main line of Firefox code, has really just started recently. So far, not really that much, and but there's been a lot of effort into it, and I'd say over the next, if you were to ask me that a year from now, my answer would be absolutely yes. Well, so the question was, if there are a lot of people who are not really knowledgeable about security, how would you start a red team? For the answer for us is that, as it turns out, there are a lot of people in Mozilla who do know a lot about security, but they just don't happen to work on security teams. And so that really hasn't been a problem for us, though we also want to get more people involved who are not security experts. And so what we're starting to do is, for example, in the web space, is introduce platform developers, for example, to things like, and also web developers to things like, proxy tools like Zap. And so Simon Bennett, who does OWASP Zap, actually works on the Mozilla Cloud Services security team. And so we're introducing these tools to developers. And the way that Zap becomes, for example, really useful to developers is a lot of them never have worked with an intercepting proxy before. It gives them a really interesting view of what's happening between the user agent and the server side that they really haven't seen before. They've seen it using the browser developer tools. It's a lot different than looking at it through an intercepting proxy. So we introduce these. It gives us an opportunity to get them interested in it, because a lot of the tools that we think of as security tools also turn out to be really useful for developers.
Okay, thank you, Adam.
Thank you.